When installing a 100 amp subpanel in an attached garage or upstairs living area, proper grounding is essential for safety and compliance with electrical codes. According to section 250.24 A5, you are required to run a grounding conductor to the subpanel. For a 100 amp subpanel fed by number 1 copper conductors, you need a number 6 bare copper grounding conductor. This grounding conductor connects the subpanel to the grounding electrode system, typically a ground rod or the metallic water pipe system, if it meets the requirements of the National Electrical Code. The purpose of this grounding conductor is to provide a low impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices such as circuit breakers or fuses. It is important to understand the difference between grounding and bonding. Grounding refers to connecting the electrical system to the earth, while bonding involves connecting metallic parts together to create an electrically conductive path. In a subpanel, the grounding bus and the panel enclosure must be bonded together. This is typically achieved by connecting the bare copper grounding conductor to the grounding bus, which is then bonded to the metal enclosure of the subpanel. The grounding conductor for a subpanel is always required to be one size smaller than the feeder conductors based on the ampacity of the overcurrent protection device protecting the feeder. For example, if you are using number 1 copper conductors for your feeder, a number 6 copper conductor is sufficient for the grounding electrode conductor to the subpanel. However, it is always important to consult the National Electrical Code Table 250.122 to verify the appropriate size grounding conductor for your specific installation. When running the grounding conductor, it is essential to ensure that it is properly protected from physical damage. The grounding conductor should be installed in the same raceway or cable as the feeder conductors. This helps to minimize impedance and ensure that the grounding path remains effective. The grounding conductor should also be securely connected to the grounding bus in the subpanel and to the grounding electrode system at the service entrance. Proper grounding is crucial for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. If a fault occurs in the system, such as a short circuit, the grounding conductor provides a low impedance path for the fault current to flow back to the source. This causes the overcurrent protective device to trip, interrupting the flow of electricity and preventing a dangerous electrical shock. It is important to note that the neutral conductor is not the same as the grounding conductor. The neutral conductor carries the imbalanced current in a 3-wire circuit, while the grounding conductor provides a path for fault current. In a subpanel, the neutral conductor must be isolated from the panel enclosure. This means that the neutral bus should not be bonded to the metal enclosure of the subpanel. The only connection between the neutral and grounding system should occur at the service entrance. When installing a subpanel, it is essential to follow all applicable electrical codes and regulations. It is also recommended to consult with a qualified electrician to ensure that the installation is performed safely and correctly. In addition to the grounding conductor, it is also important to ensure that all metallic parts of the electrical system are properly bonded together. This includes metal conduits, metal enclosures, and metal water pipes. Bonding creates an electrically conductive path that helps to equalize the voltage potential between different metallic parts. This reduces the risk of electrical shock if a fault occurs. Bonding can be achieved by using bonding jumpers, which are short lengths of copper wire that connect different metallic parts together. The bonding jumpers should be sized according to the National Electrical Code Table 250.102. It is important to ensure that the bonding jumpers are securely connected to the metallic parts. This can be achieved by using approved bonding connectors or by welding the bonding jumpers to the metallic parts. In some cases, it may be necessary to use a supplemental grounding electrode to improve the effectiveness of the grounding system. A supplemental grounding electrode is an additional ground rod or other grounding electrode that is installed to supplement the primary grounding electrode. Supplemental grounding electrodes are typically used when the resistance to ground of the primary grounding electrode is too high. The resistance to ground of the grounding electrode can be measured using a ground resistance meter. If the resistance to ground is greater than 25 ohms, a supplemental grounding electrode should be installed. The supplemental grounding electrode should be located at least 6 feet away from the primary grounding electrode. It should also be connected to the grounding bus in the subpanel using a grounding conductor. When installing a subpanel, it is important to carefully inspect all wiring and connections to ensure that they are properly made. Loose connections can cause arcing and overheating, which can lead to electrical fires. All wiring should be properly sized for the ampacity of the circuit. The wiring should also be protected from physical damage. If the wiring is exposed, it should be installed in a conduit or other protective enclosure. When terminating wiring at the subpanel, it is important to use the correct type of connectors. The connectors should be sized for the wire gauge and should be properly tightened. It is also important to ensure that the insulation on the wiring is not damaged. Damaged insulation can create a path for leakage current, which can lead to electrical shock hazards. After the subpanel is installed, it should be tested to ensure that it is functioning properly. The testing should include a visual inspection to check for any obvious problems. It should also include a continuity test to verify that the grounding system is properly connected. If any problems are found, they should be corrected before the subpanel is put into service. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. It is important to consult the NEC to ensure that your subpanel installation complies with all applicable codes and regulations. In addition to the NEC, there may be local codes and regulations that apply to your subpanel installation. It is important to check with your local building department to determine if there are any additional requirements. Installing a subpanel is a complex task that should be performed by a qualified electrician. If you are not comfortable working with electricity, it is best to hire a professional to do the job. A qualified electrician will have the knowledge and experience to install the subpanel safely and correctly. They will also be able to ensure that the installation complies with all applicable codes and regulations. The size of the grounding conductor is determined by the size of the ungrounded conductors feeding the subpanel. As previously stated, refer to NEC Table 250.122 for the appropriate size. The grounding electrode conductor connects the subpanel's grounding bus to the grounding electrode system, which could be a ground rod, metal water pipe, or other approved electrode. This connection ensures that the subpanel is properly grounded to the earth, providing a path for fault currents. It's crucial to use the correct type of connectors and make sure they are properly tightened to ensure a secure and reliable connection. A loose connection can create resistance, which can lead to heat buildup and potentially a fire. The neutral conductor should be isolated from the subpanel enclosure. The neutral bus should not be bonded to the metal enclosure, as this can create a ground loop and potentially cause unwanted current flow. The only point where the neutral and grounding system should be connected is at the main service panel. Ensure that all metallic parts of the electrical system are properly bonded. This includes metal conduits, metal enclosures, and metal water pipes. Bonding creates an electrically conductive path that helps equalize voltage potentials, reducing the risk of electric shock. Bonding jumpers should be sized according to NEC Table 250.102. If the resistance to ground of the grounding electrode is too high, consider installing a supplemental grounding electrode. A supplemental grounding electrode is an additional ground rod or other approved electrode that can help improve the overall grounding system. Ensure that the supplemental grounding electrode is located at least 6 feet away from the primary grounding electrode. All wiring and connections should be carefully inspected to ensure that they are properly made. Loose connections can cause arcing and overheating, which can lead to electrical fires. All wiring should be properly sized for the ampacity of the circuit. The wiring should also be protected from physical damage. After the subpanel is installed, it should be tested to ensure that it is functioning properly. Testing should include a visual inspection to check for any obvious problems. It should also include a continuity test to verify that the grounding system is properly connected. If any problems are found, they should be corrected before the subpanel is put into service. Installing a subpanel is a complex task that requires knowledge of electrical codes and safe work practices. It is recommended to consult with a qualified electrician to ensure that the installation is performed safely and correctly.